Hello.
अभी live नहीं हुआ.
1 second.
கேக்குதா உங்களுக்கு?
Am I audible, Akka?
Yes, you are audible. What about me?
How about public audience? Can you just check? Can you just check it once? Can you say something, Akka?
Mic
Yeah.
testing, mic testing.
Fine.
சொல்ல
Yeah,
வேண்டியதா?
that's பழைய மாதிரி போயிடலாம் அப்படின்றீங்களா?
Audio and video.
Audio and video is clear, Akka.
Okay. Thank
Let's
you.
start,
Thank
Akka.
you. Oh yes, sure, sure.
Basically, I will introduce the subject, then you,
Okay.
then to the
Okay.
subject, over to you. After that,
Yes.
if any questions are there, then we will certainly ask the questions.
Okay.
Can we go ahead?
After my presentation, question session will be there, no?
Yeah, obviously.
Okay. Okay.
Any students who would like to ask any questions can ask online. It can be
Okay.
added. It can be added.
Sure, sure.
Fine.
Sure, sure.
Shall we? We are going ahead.
Oh yes. Thank you.
Very good afternoon to everyone. Today we are on the fourth day of sixth 5-day webinar series from Gandhigram Rural Institute, deemed to be university. This has become a real good success these days. Many viewers are getting added on program wise, you can say. Internationally, it has reached because of our alumni as well as the speakers, those who are coming in. And it's a dream of our chancellor to make GRI center as hub of knowledge. So we are following every advice of our chancellor in letter and spirit. I would like to thank our chancellor for the support, our vice chancellor Dr. B. Subraj for his unconditional support which he is extending. Our registrar Dr. VPR Kumar. All these people have actually supported us in getting this as a grand success. On fourth day of webinar, as usual, we are bringing in very good subjects, very good speakers, and picking and choosing is what we are doing, and rest of the things has been the justice is done by the speakers and their subjects. It is really going to be very, very useful to our student fraternity, not only our student fraternity, but for almost all the researchers, those who are in higher education, and it will enrich people. It will be a ready reference. This is how our dream is. We are on it. Today is a special day for us because we have a very eminent speaker from Gandhigram Rural Institute today. We all call her Akka, with a lot of respect and love. Dr. S. Meenakshi, on a topic of removal of toxic pollutants from water using biomaterials. Before getting into the webinar, let me introduce our favorite Akka. She actually studied in Gandhigram Rural Institute, and she was a gold medalist right when she was studying, and after that she had joined the team of faculty, and today she is a very prominent person in our chemistry department, doing a lot of research, guiding a lot of people, and doing fantastic justice to the profession what she has chosen by lighting many students' life is what I can say. Among our 7 professors who have been awarded, they have come in 2%, within 2% of the top eminent scientists in the world. Among the 2%, which was actually an assessment done by Stanford University of the United States of America. Among the 7, we have our Dr. Meenakshi, who is one among the 7 topmost scientists who have done research in specific subjects which are new and which are commendable. When I have to introduce it's a It's a difficult task for me to introduce someone very close to us by heart, and but still very respectable. So I would like to put Akash interest of area of research is absorption, defluoridization, toxic ions, heavy metal removal, photogradants, dyes, pesticides, removal of oil from oil in water emulsion. And teaching and research experience, as I have told, she has come as a student and she has done almost 28 years of teaching, 30 years of research. Number of papers published is 178. Number of conferences organized is 6. And number of conferences, symposium attended, paper presented is 118. Number of PhD awarded to the students is 17. Number of PhD pursuing is 6. Number of projects ongoing under Akash supervision is 2. Number of projects completed is 8. And she has served as editor for various reputed international journals, and she has contributed book chapters. Total citations in H index is 6686, which speaks volume about what she has written. In H index it is 43, I-10 index it is 111, as per the Google Scholar. She is serving as a reviewer for American Chemical Society journals, Elsevier journals, Springer journals, Taylor and Francis journal, Wheely, Interscience journals, national journals. And her membership in scientific bodies and associations, she is executive board member in Indian Satin and Cytosan Society, India, and lifetime member in Indian Journal of Environmental Protection, lifetime member in Indian Desalination Association, and member in Board of Studies in various colleges in Tamil Nadu. She has been awarded as Best Researcher Award given by Indian Citizen and Cytosan Society, India. With this small introduction, I would like to welcome Dr. Meenakshi on her title, to speak on her title, Removal of Toxic Pollutants from Water Using Biomaterials. Thank you. Akar, over to you.
Thank you for your nice introduction. So, I'm happy to share my experience in the field of. Am I audible?
Yeah, you are audible.
Okay. I'm happy to share my experience in the field of water and wastewater research in Gandhigram. This type of research, Dr. Krishna Kumar may be knowing it, was initiated by Professor G. Karthikeyan and Professor B.V. Appara. Two great scholars, they are my mentors. They have initiated this type of research in Gandhigram. In fact, they have showed the seeds of research in Gandhigram, and we are harvesting the benefits, fruits of it. They
real tributes. I would say it is a real tribute to Dr. G. Karthikeyan and Dr. Appara.
And Dr. Appara. They paved a very good way for us, and it raised me up to this level. I fondly remember them, and I am very thankful to them. So I am a bit emotional when I speak about Professor Karthikeyan and Professor Appara.
Thank you.
Okay. Right. So, please. So my topic is removal of toxic pollutants from water using biomaterials. So in this slide, I have given some slogans which give the significance of water. We call water as the elixir of life. Water is Mother Earth. Everything is water. Without water, nothing is possible on the earth. If at all Third World War happens, it should not happen. If it happens, the major reason must be water. Yeah, water. Even now we are witnessing the war between two states because of water.
Not only two states. Not only two states. Sorry for cutting.
Yeah,
this is happening with the neighboring countries also.
Yeah, neighboring countries, even within the
state also.
State also. Yeah. It is mainly due to the water scarcity. It is the relationship between the availability and the demand. If the demand is more and availability is less, naturally water scarcity comes. The major water scarcity reasons are overpopulation, inadequate rainfall, uncontrolled use of water and climatic changes, and also due to industrial revolution where they use more water. So we know these are all various sources of water: rainwater, surface water, groundwater, seawater, and among which rainwater is the purest form of water and the seawater is the most impure water. And the surface and groundwater acquire the quality where they are found. That is, it acquire the quality of the soil where they are found. And how a potable water should be. So water quality parameters, limits have been assigned for all water quality parameters. So by World Health Organization, Bureau of Indian Standards, there are so many standards have been assigned for various water quality parameters. The water quality parameters, there are three types of water quality parameters: physical, chemical, and biological. Of course, for biological, E. coli must be absent. There should not be any E. coli. It will cause various diseases like dysentery, cholera, and all. And regarding physical quality parameters, color, turbidity, temperature, it will all come under physical quality parameters. So the water must be colorless, waterless, and tasteless. It must be perfectly cool. And regarding the chemical parameters, we have various parameters like pH, total dissolved solids, total hardness, chloride, sulfates, calcium, and all the chemicals, dissolved solids come under this category. And each will have a particular effect on human health. If the permissible limit for pH is 7 to 8.5. If it exceeds this limit, it causes alkaline. If it is below this limit, it will cause acidity. It will make the water unfit for drinking. Similarly, total dissolved solids, the maximum permissible limit is 1500 milligram per liter. If it is more than that, we cannot drink that water. It will cause palatability. And the total hardness, it will the maximum limit is 500 milligram per liter. If it exceeds this limit, it causes bitter taste to water. And of course, you know, chlorides, if it is more than 600 milligram per liter, it causes salty taste. And sulfate, if it is more than 400 milligram, it causes bitter taste. Likewise, I have listed out various chemicals name, and fluoride, nitrate, heavy metals. I am going to discuss in detail later part of this program. And what is the pollution? So any substance present in water which cause adverse effects on health when it is consumed, it is known as water pollution. Depending upon the nature of the chemicals present in water, it may be classified into various types. Organic pollution. Organic pollution means any substance which containing carbon and nitrogen is considered as organic pollutant. When it is dumped into water, it undergoes degradation and it will consume all the oxygen present in water, and there will be depletion of oxygen in that water body, which will lead into anaerobic digestion, and which in turn lead to toxic chemicals into the water. And finally, the water may become septic. So it will become unfit for drinking. Inorganic salts, which as I already mentioned, all calcium, sulfate, chloride, fluoride, heavy metals and all, they constitute what is called inorganic salts. So if they exceed a particular level again, it make the water unfit. Heavy metals, it also comes under inorganic group. Suspended impurities, it will make the water turbid. We cannot drink that water. Thermal pollution, if the water must be perfectly cool. If the temperature is little bit raised, it will affect the aquatic animal present in water, and also it will trigger various chemical reactions in water. So it is not advisable. And disease causing agents. This, when fecal matter mix with water, it will contaminate the water. It will become a medium for growing of various bacteria, which will lead to many waterborne diseases. So these are various types of water pollution. And as you all know, the sources of pollution may be of natural origin or it may be due to man-made sources. So natural origin means, for example, in Dindigul district, there is no fluoride polluting industry in and around Dindigul, but still we have identified more amount of fluoride in drinking water. It is mainly due to the nature of the soil. Our soil found to contain fluoride-bearing minerals. Due to leaching of fluoride from the soil, it has entered into drinking water. So the natural origin may be one source, and man-made sources. It is due to untreated effluents from various industries, waste from houses and agricultural runoff. We are using pesticides for agricultural purpose, so they may also contaminate the nearby drinking water source and nearby soil, then into the groundwater. So strategies for saving water, the charity should begin at home. We have to save water. We have to uh, we will save water only when we value the water. And the rainwater harvesting system we have to adopt. I think Tamil Nadu is one of the best state which follow the rainwater harvesting system. And reuse and recycle. Well, all the developed countries, they are recycling the water and again using the same water. India is the only country where we are using water for only one time. We are not following this recycling and all. And for recycling, we need some sustainable technologies. Then only we can recycle and reuse it. So these are all the research work we are carrying out in the Department of Chemistry. That is fluoride removal, heavy metal removal, oil removal, nitrate and phosphate removal, dye removal, pesticide removal. So all these problems are endemic. So we have identified fluoride toxicity in and around Dindigul, heavy metal removal, because there are so many tanneries in and around Dindigul. So because of their the effluents, we found to contain the many of the drinking water sources found to contain heavy metals in the water, and nitrate phosphate also in the drinking water. Dyes, Chinnalapatti is a famous textile center. They have domestic dyeing units. So that dyes, it has polluted the nearby areas. And also we have identified some pesticides in the drinking water. So all these problems are endemic problems. They are all local problems. So we have taken up these problems for our research. And for water treatment, various technologies are available like desalination, reverse osmosis, membrane filtration, ion exchange, electrocoagulation, precipitation, adsorption. Depending upon the nature of the pollution, we can select the technology. So among which we have selected adsorption, ion exchange, and now we have started preparing membrane also. And many of our materials are adsorbents because it is low cost, and even at if the pollutants are even at very low concentration, we can effectively remove using the adsorption technique. And the main advantage of adsorption is once the adsorbent is exhausted, that can be regenerated and can be reused. It makes the process cost effective. So normally we prefer the technique adsorption. So we have developed so many adsorbents in our laboratory for water treatment. And these are all various adsorbents we have prepared, that is activated alumina, activated carbons from various biomaterials, then biopolymers, chitin, chitosan, alginate, etc. And we have also used some synthetic polymers. We have mixed synthetic polymers with biopolymers in order to make it more stable, and polymeric resins, that is synthetic and commercially available resins also we have used for our research work. And mainly, I'm going to focus on biosorption. That is, the biosorption means material which are derived from animal or plant kingdom. So they are highly stable, they are cost effective. The major main advantage is they are biodegradable. So the materials which we prepared for water treatment will not cause any secondary pollution. They are easily biodegradable and hence they are environmentally friendly. And these are all the normal materials, that is biomaterials we used to prepare. That is wood, straw, rice. We make a carbon out of it and used for water treatment. Of course, they are all working well. They are effective in removing the pollutants. But for technology transfer, we have to see the sustainability. So even though they are working well, again and again the same material cannot be reused after regeneration because of their low mechanical strength. So we have opted for biopolymers, and now we are using biopolymers for our work. And this activated carbon we have used, and even now activated carbon is the best material for removing the color. And now carbon dots and all, so the activated carbon is the basic material. So we are using activated carbon as well as the biopolymers. So these are the various biocarbonized materials we have used. As I told you, they are all very good adsorbents, but their sustainability is little bit less. Therefore, I am not going to project the mechanism or technologies developed by these materials. I am going to project only the materials derived from biopolymers. So these biopolymers, I have used chitin and chitosan. They are obtained from sea animal. The major advantage of these biopolymers are they are biocompatible. They mix with any material. They are biocompatible. They are biodegradable, so environmentally friendly. They are non-toxic. They are abundant, and hence they are cost effective. And they have multifunctional groups. In chitosan, they have amino group and hydroxyl group. So they can be modified according to our need. So suppose if we want to remove fluoride means accordingly we can change those groups. So fluoride is negative ion, this amino group positive. So they can attract with each other. So according to our need, we can modify this chitosan. Therefore, we have selected chitin and chitosan as our basic material for preparing various adsorbents for the effective removal of various pollutants. So here I have given some of the biopolymers: starch, lignin, alginate, chitin, and chitosan. So among which we have selected chitin and chitosan and prepared materials. So as such, all the any biopolymer, they are very weak. Their mechanical strength is very less, and their form, they are like flakes. So if we develop technology, when we add water, this will not, if it is in the powder form, it will allow the water to come out. The filtration ability will be less, pressure drop will be there. Therefore, we have to make into the form of beads. So normally we will take the biopolymers and made them in the form of beads or composites, hybrid materials, and then only we use it. And then we make chemical modifications. That is, we will do cross-linking in order to provide a mechanical strength, and we make them in the form of composite. So composite is a material which consists of both organic and inorganic materials. Inorganic materials, they are rigid, whereas organic, that is chitosan, considered as organic medium, it is highly flexible. So when we mix this organic and inorganic materials, it will give medium properties. That is, it will not be highly rigid or highly flexible. So it will have a acoustic properties. So we have prepared composite materials using chitosan and many inorganic materials. And also we have done various chemical modifications like protonation, carboxylation, grafting, complex formation, blends, etc. for in order to suit our requirement. So after preparing these adsorbents, normally we do these characterizations. So yeah, using IR, SEM, ADAX, XRD, TGA, AFM. So whether the groups which we have introduced or actually introduced, what is the thermal stability? So what is the surface area, how the surface is, whether it has been, the pollutant has been absorbed on the surface, how it is bare surface, how after adsorption the surface appear. So all these things we will characterize using these techniques. Most of these instruments are available in our laboratory except AFM. Almost all the instruments are available in our laboratory. And this is the common scheme of adsorption study. We use both batch and column studies. So normally we optimize various parameters like contact time, dosage, pH, and all. So for example, we will take an adsorbent and we will optimize what is the minimum contact time for maximum removal. So we will optimize the contact time and dosage. What is the minimum dosage required to bring down the pollutant into the desired level? pH plays an important medium. See, if the pollutant is negative, we have to make the medium as the positive. Our medium means our adsorbent should be positive. So this pH plays a very important role. So depending upon the nature of the pH, the adsorbent surface may acquire either positive charge or negative charge. So we will optimize the pH. And we also do the influence of other coions. Normally in water, apart from this pollutant, other ions will also be present. So they will also compete with our particular pollutant for the surface site of the adsorbent. So our surface adsorbent should be selective for the particular pollutant. If the fluoride is more, the material which we prepare must be selective to fluoride. Therefore, we will see the influence of other ions present in water and we will select the best material which is highly selective for a particular pollutant. And of course, we do the experiment with the different initial concentration temperature study in order to establish the mechanism, in which mechanism the fluoride or any pollutant is being removed. And the important experiment is reusability. So after some time, the surface adsorption is a surface phenomenon where when this adsorbent is in contact with the pollutant get adsorbed over the surface of the adsorbent. Once the surface get exhausted, so it will lose its capacity for further adsorption. So at that stage, we have to regenerate the adsorbent, and after regeneration, the same material can be reused. So we have to test the suitable regenerant. So what is the regenerant which can elute the adsorbed pollutant? So that regenerant for all the adsorbent materials we have identified, and the same material, how many times we can reuse, that also we have tested in our laboratory. So which will make the material cost effective. And normally, these are all the various mechanisms I have given. Normally, the pollutant removal follow one of these mechanisms. It may be ion exchange or adsorption. It may be physical adsorption or chemical adsorption or by complexation, or sometimes it may be combination. Ion exchange adsorption may combine in removing the pollutant. So I am going into fluoride pollution. When this element fluoride, when it exceeds the limit 1.5 milligram per liter, it causes a disease called fluorosis. The World Health Organization fixed the limit, maximum permissible limit for fluoride as 1.5 milligram per liter. Drinking water is the major source for fluorosis. As this fluoride is a negative element, it has an affinity for calcium and phosphate, and hence it is retained by bones and teeth, where our bones and teeth has more calcium and phosphate. So it causes a disease called fluorosis. Three types of fluorosis has been identified. One is dental fluorosis, second one is skeletal fluorosis, and third one is non-skeletal fluorosis. So the dental fluorosis, the symptoms is discoloration of teeth. Our teeth is nothing but calcium hydroxyapatite. When fluoride enters into the teeth, it will replace hydroxyl groups of the calcium hydroxyapatite. And as the concentration of fluoride become more, the color may change from pale yellow to brown and even to black. Little amount of fluoride is essential for hardening of teeth, but when the same fluoride is in excess, excess, it will sometimes it brittle. It may
Damage.
pitting, it will pitting of teeth may also occur. So this fluorosis, dental fluorosis, cannot be reversed. And skeletal fluorosis, normally this fluoride gets deposited into the bones where calcium is more as calcium fluoride. It acts as a paste. So it makes bones, neck stiff. So a person affected by skeletal fluorosis cannot move his head freely. He cannot walk. It causes stiff neck, pain on joints, stark backs, and bow legs. So finally, it will restrict the movements. We call fluoride as a slow poison. Okay. But we have not observed any skeletal fluorosis victims in and around Dindigul, but we have observed dental fluorosis victims. And it is from the literature, it is known that this fluoride not only affect the calcified tissues, it also affect the non-calcified tissues like thyroid gland, lungs, kidneys, and all. It is reported in the literature. And we have used these polymeric materials for removing the fluoride. So this is, it involves more chemistry. Anyway, I cannot avoid this also for the sake of students. So I think they will understand this. And we have made this chitosan, which has the amino group, and it has been protonated. Protonated means a plus charge has been introduced into this amino group, which has electrostatically attracted fluoride. So fluoride is attracted on protonated chitosan bead. Okay. Then we have also prepared carboxylated chitosan beads. So here I have given the schematic diagram of making of carboxylated chitosan, and then this carboxylated chitosan electrostatically attract fluoride. And we have also seen chitosan has amino group and hydroxyl group. Amino group can be protonated and hydroxyl group can be, so that can also be made into carboxylated chitosan group. So we have separately done carboxylation and protonation. Here we have done both amination and carboxylation. So now this protonated and carboxylated chitosan beads showed higher efficiency for fluoride removal. Okay, so these three materials, these three modifications we have made and removed fluoride. And we have also incorporated metal ions into this chitosan. Chitosan has lot of amino groups. They act as a chelating agent. They form complex with metal ions. These metal ions, they are positive, which in turn attracted fluoride. So we have introduced metals, that is rare earths. It will not easily leach out. So it will not pollute the water which we are treating, and they will strongly form a bond with the chitosan. They will immobilized into it, and which in turn electrostatically attract fluoride. So we have also prepared metal loaded carboxylated chitosan bead, zirconium loaded, lanthanum loaded, and also they are rare earths. They will not easily leach out from the adsorbent. So we have used those metals, and they are all high positive, possess high positive charge compared to H plus. They are highly positive and hence more easily attract fluoride. So these metal loaded carboxylate chitosan beads are effective in removal of fluoride. And we have also used some composites. As I told, we have mixed chitosan and inorganic material. So for example, alumina, it is highly effective in removing fluoride, but it is somewhat rigid. It is in the powder form. And chitosan, it is somewhat flexible. When we mix alumina and chitosan form, they are compatible with each other, and we can made, this composite can be made into bead form or candle form, so that it can be make use of making water filters. So easily, that is, technology transfer is easy with these composite materials. So we have mixed alumina and chitosan. So both alumina and chitosan are capable of removing fluoride, and when we mix it, they are not very soft, they are not too rigid, so they possess medium properties, medium mechanical, enough mechanical strength and all. So we have made composites with alumina and chitosan. In alumina, we have aluminum Al3 plus group, OH minus group. So this aluminium attract or remove fluoride by electrostatic interaction. The hydroxyl groups get exchanged for fluoride. They are similar charges. So hydroxyl groups are replaced by fluoride. So by ion exchange as well as electrostatic interaction, this material remove fluoride. And nanohydroxyapatite chitosan composite. So nanohydroxyapatite, it is also a very good inorganic material which is capable of removing fluoride. It is also in the form of powder. As such, it cannot be used for technology transfer because this powder form will affect the filtration ability of the material. Therefore, and it is rigid. Therefore, we have mixed with chitosan. Chitosan, because of the amino group and hydroxyl group, capable of removing fluoride. But anyway, when we mix it, the synergistic effect works here. Both are capable of removing more amount of fluoride. So here also the mechanism followed are adsorption as well as ion exchange. So all the details are published. I have given mentioned the journal in which it has been published. So for reference, people can refer this. And hydrotalcite, again, it is an inorganic material at chitosan. So here also the material, composite material, removed fluoride by ion exchange as well as adsorption technique. And we have used magnesia chitosan composite and magnesia and chitosan. Again, the same mechanism followed for the removal of fluoride. And by nanohydroxyapatite, chitin also, it is not only chitosan, chitin also capable of removing fluoride. We have made chitin composites with inorganic material. And we have prepared dendrimer like polyamidoamine functionalized chitosan beads. That is, we have also added some synthetic polymers also into our chitosan polymer, which made our chitosan beads more stable. So this material is capable of removing fluoride by electrostatic interaction. And we have also mixed chitosan with conducting polymers. So these polymers, once again, this increased the stability of the material, chitosan and bioconducting polymeric mixed polymer. So this also removed fluoride by means of electrostatic interaction and ion exchange. So this is one more material, chitosan imido acetic acid functionalized macroporous polystyrene resin blends. Blends means we are blending inorganic, synthetic as well as biopolymeric materials for fluoride sorption. And so only a few sorbents which showed higher capacity for defluoridation I have showed. And then heavy metal comes into heavy metal toxicity. This is also we have been doing for a very long time because the tannery pollution is very common in Dindikal. From the tannery, some heavy metals like chromium, zinc, copper, they are leached into many of the groundwaters, and so without any treatment, they have discharged their effluents. It has polluted the nearby areas. And so we have started this type of research, that is heavy metal removal in our department. So heavy metals, their density is more than 5 times higher than water. So they cannot be degraded or destroyed. It is not biodegradable. Therefore, it will remain on the earth crust and it will enter into the drinking water and cause pollution. Even at very low level, they are highly toxic. Sometimes they may lead even to death. Therefore, heavy metal toxicity is considered as a very serious problem. And the sources may be, as I told you, it may be of natural origin and man-made sources. And how these heavy metals affect the human body. Some of the heavy metals are essential for various metabolic activities that are taking place in our body. Most of the, but when the same heavy metal, they are in excess, it will converted as a pollutant. It will lead, it will cause adverse effects on our health. Our enzymes, which are responsible for various metabolic activity in our body, is a proteinous matter, which has sulfur hydrogen bond. Okay, so when the metal ion enters into our body, this metal ion replaces the hydrogen from the sulfur. That is, it will, instead of hydrogen, this metal ion will go and sit with sulfur. That is, it will have a bond with sulfur. So enzyme is like a catalyst. Only when it has SH group, it is active. It will metabolize all the activities in our body. When this H is replaced by a metal atom, the enzyme activity will be suppressed. So slowly all the metabolic activities in our body will be suppressed, and finally it will lead to death. So each metal has target a particular type of enzymes, and it will immobilize that particular enzyme, which in turn immobilize that particular metabolic activity, which catalyzes. So these heavy metals are non-biodegradable and highly toxic. And at a large scale, we can think of when we reuse these valuable metal ions, because we can, when we use adsorbents, the metal ions get adsorbed over the adsorbent, then we can regenerate those metal ions and that can be reused. And also as a preventive measure, we have going for various technologies for heavy metal removal. So here I have listed out some heavy metals and their ill effects. Mercury too, it causes a disease called Minamata, because Minamata is a river in Japan. In that near that there was an chloralkali industry, and they were using electrodes, mercury electrodes. So the damaged electrodes they have disposed into that river, and the mercury present in that electrodes are in that water. So those who have used, that is particularly that fish and all, so they have consumed this mercury through food chain. They entered into the people, and the people, after some time, many non-vegetarians, they developed some brain damage, that is mental disorder. Then only they have identified the reason is the mercury from that river, Minamata River. That is why this disease caused by mercury is called Minamata disease, the major symptom of which is brain disorder. And arsenic, as you all know, it is highly toxic. It leads to death because it will affect DNA synthesis. And DNA is the important component of our human body. When it affects DNA, it will lead to death. Cadmium too, it causes a disease called itai. Itai means in Japan, it is paining. It will affect the bones and the enzymes which are responsible for the formation of bones. So when it target because in the bone we have an enzyme which contains zinc. Zinc and cadmium resemble each other. So this cadmium, when it enter into the body, it will replace the zinc enzyme, which is responsible for the formation of bone. So when cadmium is replaced, zinc, this cadmium will suppress the functioning of that particular enzyme, and that will not function. Therefore, the bone growth will not be there, and it will become weakening, and it causes the disease called itai. Similarly, zinc 2, it causes lungs edema. Chromium 6, it particularly targets the enzyme which is responsible for the development of skin. And lead, it will interfere with hemoglobin synthesis, and naturally it may lead to anemia, and likewise nickel. So these are all some of the heavy metals I have listed out, and we have carried out adsorption studies and identified materials for the removal of these heavy metals in our laboratory. So as I told you, this Minamata disease is mainly due to mercury. The main symptom of Minamata is mental retardation, blindness, and it also causes kidney damage. And here is the victim poisoned by mercury. So here I have shown in this figure. And the cadmium, it will affect the bones, it weakens the bones, So it will cause a severe pain in bones and joints. That disease is called iti. So it will affect the kidney also. It will lose their function. And zinc. So zinc, mainly the main sources of zinc is through paints, batteries, melting, fertilizers. Some of the pesticides found to contain zinc. So it will influence the activity of microorganism and affect the soil fertility. It will increase the acidity of water and zinc poisoning. So small boils they may occur because of presence of zinc. And arsenic, it is very, very important. It is a metalloid. It will interfere with the ATP generation, which is highly responsible for in our ATP generation is major function that is taking place in our body. So this arsenic interfere with this ATP generation. That is, it will interfere, it will replace phosphate, ATP, adenine triphosphate. It will interfere with the phosphate. Instead of phosphate, arsenic will enter. It will become adeno triarsenate, it may become. So it will stop the DNA protection. So naturally, it will lead to death. So initial stage, there will be loss of hair and nail, hearing problem and digestive difficulties, and at a very, very lower stage, and an acute stage, it may lead to coma and death. It is very common in West Bengal, but there many methods have been developed by them. So this is some of the victims affected by this arsenic poisoning. And we have used again that chitin and chitosan for heavy metal removal. So we have modified chitin and chitosan according to our need. So these are all the various forms, that is protonated, carboxylated, and we have introduced many amino groups into our polymeric chain, so that we have enhanced the amino groups into the chitin and chitosan, which in turn enhanced the removal capacity of heavy metal. And in heavy metal, we have major work has been done on chromium 6 removal. Chromium 6 is highly toxic, and earlier we have observed chromium 6 ions in drinking water because of this tannery pollution. So we have concentrated mainly on chromium. Even though it is a metal, when it is in water, it exists as an anion, chromate ion. So this is a negative ion. So electrostatically, we were able to remove chromium from drinking water as well as the effluents. So like fluoride, we have used protonated chitosan beads, carboxylated chitosan beads, metal-loaded chitosan beads. So when we enhanced the positive groups introduced positive groups into chitosan, so they were able to absorb fluoride electrostatically. And we have also introduced metals in order to enhance its positive charge, which in turn remove fluoride, chromate ions by means of electrostatic interaction. And we have also, so the same, when we consider other heavy metals like lead, copper, zinc, and all, so they can be removed by means of ion exchange. So ion exchange means similar type of ions get exchanged. It all depends upon the exchange depends upon the concentration, size, charge of the exchanging ions. So according to the nature of the pollutant, we have modified the material, our adsorbent material, and using the ion exchange technique, we have removed various heavy metals like copper, zinc, lead, cadmium, mercury, and all. So we have also used SiC, that is lanthanum loaded silicon chitosan beads, silicon chitosan beads. When silicon is introduced into chitosan, so we can get composites. And another thing is the silica, when we can make it as a composite, and then when it is removed, it will the silicon can be later on removed. It will produce small pores into the material, so that pores can absorb metal ions. So we have made lanthanum, chitosan, silica composites and silica chitosan composites, which were able to remove fluoride by means of electrostatic interaction. And we have removed chromium, lead, cadmium ions using polyaniline chitosan composites. So I told you polyaniline is a conducting synthetic polymer, chitosan is a biopolymer. So we have mixed both, and this due to synergistic effect. Polyaniline has a more amino group, chitosan also has more amino group. Both combined together and able to remove more amount of metal ions. Their strength, stability is also more. So these materials also we have prepared for the removal of chromate, lead and cadmium. And removal of chromium, lead and cadmium using polyaniline chitin also we have made as a composite with the polyaniline. They were also, this material also able to remove more amount of heavy metal which we have selected. And this is one more material, polypyrrole. All these conducting polymers, they have amino groups. These, our chitin and chitosan, they also have amino groups. So these amino groups are the magic group present in our material. They were able to remove these heavy metals. And we have removed chromium, this using biopolymeric assisted oxyhydroxide materials. And next comes to dyes pollution. So as I already mentioned, Chinnalapatti village of Dindigul district is a famous textile center in Tamil Nadu. The effluents from these industries we have characterized, and we have assessed the extent of pollution due to these effluents. As a consequence, we have prepared various materials for removing these dyes from the effluents, not from the drinking water, from the effluents. And of course, these effluents polluted the nearby drinking water. Most of the drinking water found to contain various water quality parameters in very high amount. That also has to be taken care. So dyes adverse effects. So the colored effluent, when discharged to land surface, it will affect the soil fertility, groundwater quality. When it is mixed with aquatic streams, it will affect. It will so that water become turbid. So the penetration of sunlight into the water body is difficult, and it will ultimately affect the aquatic animals present into it. The aquatic animals are considered as the natural purification system of water. So when it is affected, so that whole that aquatic animals uh, it will be toxic to aquatic animals. Then even very small amount of dyes, that is even if it is less than 1 ppm, it is highly visible, it is undesirable. So it has to be removed. So these are the symptoms of dyes pollution. And for dyes molecules, we have used both adsorption and one advanced oxidation process method. This is the very good method for degrading the dye molecules. The dye, whatever be the dye, it can be degraded into carbon dioxide and water. So we have used adsorption method also, but the effective method is advanced oxidation process. So that I am highlighting. So for this photocatalytic studies, these are all the common scheme. We have to identify the maximum. We normally for photodegradation studies, we use UV light or visible light. So we have to identify what is the minimum irradiation time, how much time the effluent is irradiated with UV source or visible source. And I told you pH plays a very important role to make the our medium as positive or negative. So we have optimized the pH and the dosage of the photocatalyst, influence of coexisting ions, the intensity of light. H2O2 it is used as an oxidizing agent, and different initial and dye concentrations. We have used this photocatalytic degradation method for the degradation of dye molecule and also for degradation of, that is, removal of chromium 6. So metals can also be removed using this photocatalytic method. So that we will see. So in general, So photocatalyst, they are highly effective, and this photocatalyst, they absorb light. When light is given to this photocatalyst, an electron from a valence bond go to the conduction band. So a hole is created in the valence band, and excess electron will be in the conduction band. So they will, with the water, they will be converted as hydroxyl group. That is, whole is converted as hydroxyl group, and this oxygen electron is converted as superoxide. And this hydroxyl groups or hydroxyl radicals, these radicals are capable of degrading dyes. So by means of photo oxidation, they degrade dye molecule into water and carbon dioxide. And also this superoxide radical, they are also capable of degrade dye molecules. In addition, these oxygen radicals, they reduce, for example, chromium. Chromium, it exists in two forms, that is chromium 6 plus and chromium 3 plus. Chromium 6 plus is highly toxic than chromium 3 plus. This oxygen radical, it will reduce chromium 6 plus into chromium 3 plus. This is which is less toxic compared to chromium 6 plus. Therefore, we have used this photocatalytic oxidation method for removing dyes as well as chromium 6 from FDMs. And we know this UV light, it is harmful to human being. So normally when we do this photocatalytic reaction using this UV radiation, we use some special, we do some precautionary measures. We will not see the light directly. We have to wear glass and all. In the solar spectrum, we have visible region also. It is less harm. It is not at all harmful to human being. So we wanted to exploit the visible light from the solar spectrum. So if the band gap is 3.6, it will absorb. The absorbent band gap is 3.6. It will absorb UV radiations. If the band gap is reduced to less than 3, that is around 2.6 to 2.3 electron volts, that material can easily absorb visible region. That also do the same work. When the visible light is absorbed, hole and electron pair is created, and both are capable of reducing the dyes and heavy metals. Therefore, we have reduced the band gap of the photocatalyst. Normally, photocatalyst, titanium dioxide, zinc oxide, or photocatalyst, we have selected zinc oxide because of its cost and all. So we have blended zinc oxide photocatalyst with chitosan, and we found that this addition of chitosan reduced the band gap, so that this material is capable of absorbing visible light. So we have made this photocatalyst as a absorber of visible light by mixing with chitosan. So, and we have carried out all the experiments in the presence of visible light, which is less harm. So we have prepared chitosan titanium dioxide composite, titanium dioxide impregnated chitosan composite beads, zinc oxide impregnated chitosan beads. We have mixed photocatalyst and chitosan, and those materials have been used for degradation of dyes as well as the chromium removal. And same mechanism, that is when energy is given, there is separation of, there is formation of hole and electron pair. So they should not combine again. So if they combine means there will not be any photocatalytic reaction. So they will remain as such. Hole we need separately and the electron we need separate. They will be with water, they will be converted as hydroxyl radical and superoxide radicals. They are capable of removing dyes and also heavy metal, that is chromium. And this is the same, that is chromium 6 has been reduced to chromium 3, and this H hole, They are converted to hydroxyl radical, which degraded our dye molecules. And then oil pollution. That this also we have carried out some work in our department. One of my research scholars is working in Indian Oil Corporation, Delhi. He registered under my guidance for PhD under my guidance. He came with one problem. He said they were using hydrocarbon uh, for lubrication purpose and cutting purpose. So this oil is go as a waste. When it is mixed with water, with the water there may be some salt. It form a stable oil water emulsion. So we want to have some technology which separate oil from wastewater. So that is why we have started this type of research in our department. And this oil pollution, this oil spills from the tankers or due to accidents, this oil may spill into water streams. So this will form a cover over the water surface and which will not allow the sunlight uh, penetrate into the water. So the aquatic animals find it difficult for their photosynthesis, for their movement. So ultimately they may die. And this water, so this oil may get so seabirds also affected. So in their wings, the oil may be coated. They cannot fly, and they cannot withstand temperature. Also, the oil may receive more heat from the sunlight. So ultimately, they may die. So in aesthetic sense, also this oil pollution is not desirable. We cannot use the beach and all when the sea is polluted with oil. So so we have done this oil pollution in our laboratory, and this mainly we have considered cutting oil pollution because hydrocarbon oil is used for cutting purpose in many industries for as a lubricating oil, drilling, milling, grinding purpose. So during this process, this oil is coming as it is mixed with metals also for cutting, turning, milling, grinding process. So some metals also get dissolved into it, and with the metal ions, these oils will come out and it will mix with the nearby water. It is highly undesirable. Therefore, we have done some work in the recovery of oil from water also. And for that, we have this oil is hydrophobic. Therefore, we have made our material as hydrophobic, and we have used this chitin and chitosan for the recovery of oil. So, oil formed a stable emulsion with water. First step is we have to separate oil and water, and then we have to remove oil from water. And these are the various materials we have prepared, lanthanum loaded carboxylate, chitosan beads, and all for the recovery of oil from water. Hybrid composites we have made. And this is metal incorporated chitin. So chitin is more hydrophobic than chitosan. So this showed a higher capacity for oil removal. And then nitrate and phosphate. Many of the water samples in the selected areas of our Dindigul district found to contain higher levels of nitrate and phosphate. So we have gone for this research also, that is removal of nitrate and phosphate from drinking water. So many materials we have tried, and I am highlighting only the material that is sustainable materials made out of chitin and chitosan. So nitrate and phosphate, the water, clear water is called oligotrophic. That is, it is very clear. Okay. When it is mixed with, it is contaminated with nitrate and phosphate. So normally this nitrate, NPK, nitrate, phosphate, and potassium are considered as nutrients for the growth of plants. Okay. When it is mixed with water, it will trigger the growth of algae and fungi. So after some time, this water body is covered with seaweeds, that is algae growth. So when it is covered with seaweeds, there is no penetration of sunlight. Naturally, the natural purification system, that is aquatic animals, they find it difficult. Their survival become a problem. and which are considered as the natural purification system of water. So they will die, and this algae, they will emit some toxic chemicals also, which is harmful to human being. Then the whole water body, when the nutrition, that is nitrogen and phosphate, is more in amount, that is the water body is enriched with nitrate and phosphate, there will be, it will trigger the growth of this algae, and it will, full water body is covered with this plant, that is algae, and which cannot be used for our purpose. And after some time, the when water gets evaporated, it will remain. That condition is called eutrophication. Oligotrophic is the clear water. Eutrophication means it is fully covered with the algae that cannot be used for any purpose. This algae, it will again cause organic pollution. It will deplete the oxygen level of that water body, and it will make the water into septic. That condition is called eutrophication. The enhanced growth of this algae is called eutrophication. So this again, both nitrate and phosphate are responsible for this eutrophication. And this nitrate, normally this nitrate, when it is consumed, it is converted as nitrite, which will form a bond with the hemoglobin, which affect the oxygen carrying capacity of the hemoglobin. Normally, this is found in infants, not in adults, in infants. So this oxygen carrying capacity becomes low, the baby becomes blue in color. That is called methemoglobinemia, the disease name, or otherwise it is called blue baby syndrome. So these are the ill effects of nitrate and phosphate. So the according to World Health Organization, the maximum permissible limit for nitrate has been fixed as 50 milligram per liter, whereas for phosphate it is only 0.1 milligram per liter. We have observed more than 150 milligram per liter for nitrate, and for phosphate we have observed more than 50 milligram per liter. So we have started doing this research for the removal of nitrate and phosphate. Again, the source, it may be our atmosphere, earth crust, they found to contain more amount of nitrogen and phosphate minerals. They are soluble in drinking water, so naturally it will contaminate the water. And man-made sources, many of the pesticides, they found to contain nitrogen and phosphates. Food industries, detergents, soaps, they have phosphates. So naturally, they will contaminate the drinking water. So again, the same biopolymeric hybrid materials we have used, that is inorganic and organic material, that is chitosan and some inorganic material we have blended. Composite hybrid materials we have used, chitosan as such we have used. So nitrate and phosphate using metal loaded chitosan beads we have done. Nitrate was removed by means of ion exchange mechanism, and phosphate was removed by complexation mechanism. This is the general mechanism. Accordingly, we have modified our material. And this is lanthanum 3 loaded cross-linked chitosan beams. This lanthanum form complex with the phosphate and thus removed nitrate. And here is an absorption of nitrate and phosphate, zinc loaded cross-linked chitosan beads, carboxylated chitosan cross-linked chitosan beads. By means of ion exchange, nitrate has been removed. By means of complexation, phosphate has been removed. And lanthanum loaded silica chitosan composite. Here also this silica, when it is washed, we have made a composite with chitosan, and when we wash with an alkali, silica will come out and it will create void in the composite. That void, that pores will keep some nitrate and phosphate also. So this material also capable of removing nitrate and phosphate. And we have prepared quaternary ammonium chloride functional isotopes and beads. This for the first time we have made this type of materials for phosphate nitrate in our laboratory. Nowhere it has been reported. And this is also one of the novel material using melamine formaldehyde resin for the removal of nitrate from water using chitosan also. So this also, we are the pioneers in the synthesis of this type of materials for the removal of nitrate and phosphate. and chitosan grafted. We have grafted quaternized resins into the chitosan surface so that it can remove more amount of nitrate. So then comes pesticide pollution. Recently, we have started this type of pollution. One of my student taken up this project. He has analyzed some of the water samples near Madurai, where he's living, and he identified some insecticides are present in that water system. So we have started removing a few selected pesticides, that is phosphate pesticides, for our, that is organophosphate pesticides, prophenophos pesticide, which are highly harmful. So we have started working to remove this type of pesticide. So he had a chance to visit South Korea, where he has prepared 2D, 3D, and metal organic framework materials, and phytosan also they have blended, and they have prepared 2D, 3D, and metal organic framework materials for selective removal of pesticides. In collaboration with South Korea professor, we have done this type of work. That is, we have introduced, so earlier we have used only biopolymers and a few synthetic polymers we have used. Now that we have started using this metal organic framework material, because its regeneration capacity is more. So its absorption capacity is also more. So in collaboration with South Korea, one of the universities in South Korea, they have started doing this, preparing this material and using this material for removal of pesticides. So here he has given this 2D based photocatalyst. The mechanism is by means of photocatalytic. They have prepared 2D, 3D materials with chitosan, graphene, and metal oxides, and photocatalyst, that is zirconium oxide, either zirconium oxide or titanium dioxide. And then it has been used as a photocatalyst for the degradation of the pesticides. So here some of the schematic diagrams are given, and this is also one more material and another material. So these are all published in the various journals. I have given the name of the journal also for the reference. And the important part, any university, apart from teaching research, extension is the third component of the any university.
Absolutely.
So as a part of extension, what we have done is we have identified all the fluoride endemic villages in and around Dindigul district by analyzing the water samples. So we have identified safe, what are all these sources which are safe for drinking, what are all the sources which are unsafe. They can be used. So we have identified and informed, we have created awareness among the people. We have informed them these sources can be used for drinking purpose. These sources can be used only for bathing and washing purposes. And we have a door-to-door survey we have made. So normally this fluorosis, dental fluorosis is common among the children, that is children more than age of 12. So we have we have visited various primary schools, and with the help of a doctor, we have identified the dental fluorosis, and we have created awareness as well as made a survey and the percentage of fluorosis. And then as we have suggested, we have submitted a report to Government of India. Professor Karthikeyan has got one project. So in which when I was a student, we have done this type of work, and we have analyzed all the drinking water. We have identified fluoride endemic areas. There are 12 blocks in 14 blocks in the Dindigul district, out of which 12 blocks have been identified as the endemic blocks. Only 2 blocks, Athur and Kodaikanal, they are safe. All other blocks are fluoride endemic. And we have also made a map of the endemic areas and submitted the report to Government of India for provision of safe drinking water. And then we have developed alumina technology for defluoridation at domestic level as well as at community level. Tamil Nadu Water and Drainage Board, they have sanctioned 20 lakhs for installing this community defluoridation plant in um, more affected endemic villages, and we have installed 16 plants in 16 villages. Now that, and then handed it over to the quad board, but now that it is not functioning because safe drinking water has been provided through pipelines into that villages. So for giving safe drinking water, we can through pipelines the water can be given. Only the final option is the technology. Okay, wherever if we are able to give safe water through pipelines, that is the best option. If there is no other option, we can go for defluoridation technologies. And I have been sanctioned one project by DST to evaluate various defluoridation technologies available in India. And at our and I have tested all such technologies at our field conditions, and I have come out with the best technology. So we have identified activated alumina as the best technology for defluoridation as of now. And simultaneously now we in our laboratory we are making, as I have given, that is chitosan based materials we have prepared. So we are going to analyze, that is we are going to select the best material out of the all available material based on various factors like their capacity, their selectivity, their regeneration ability, cost and all. We are going to select the best material for technology transfer. And this the technology, alumina technology, at the domestic level we have developed, and the same has been extended as for community level, that is community defluoridation plant. This has been installed in 16 villages of our district. And regarding heavy metal pollution, so as I told you, this Dindigul, there are 62 tanneries are located in and around Dindigul district. So we have scientifically measured, that is the extent of tannery pollution by analyzing all the water as well as soil samples, and we have found to contain these samples found to contain higher levels of chromium. That is why we have started methods for the removal of chromium, copper, lead, iron, and all. So we have identified the extent of pollution and the impact of this tannery pollution on ecology of the area and its influence on the economic status and living conditions of the people. Also, we have studied and we have fixed the norms to pay compensation in monetary terms to the people who had been severely affected by the environmental ecological loss. The report was submitted to the government. The government of India has sanctioned a project to Professor Karthikeyan, that is authorities of loss of ecology. So we have identified the quantum of tannery pollution and also fixed the norms to give compensation to the affected people and submitted to Government of India. So based on our report, the High Court given direction to the tannery owners to pay compensation to the affected people. So according to Gandhiji, all the laboratories are devil's workshop unless they serve the poor. So we have established many materials, but the benefit, real benefit should reach the people one only when there is a transfer of technology. So that is in progress, and I hope soon we will be come out with the technology for the removal of selected pollutant, or we will develop a technology for the removal of ions in combination also. That work is in progress. And these are all the various funding agencies. I have received funds for doing my research. So DST for defluoridation studies, I have received funds. DRDO for heavy metal removal, UGC for defluoridation and also for dyes removal, CSIR for oil removal. Again, the biotechnology. Now it is I'm running this project for this is for the removal of nitrate and phosphate. to the tune of 2 crores. I have received the funds from this funding agency, and with these grants, I have set up a water lab in our department, which has all the minimum requirements for testing the water. And I have to thank our Chancellor for the opportunity given to me, and of course to Dr. Krishna Kumar, who have contacted me and the organizer of this webinar. Thank you, Dr. Krishna Kumar. And I thank the Vice Chancellor in charge, Registrar, for their support. And I thank all my colleagues who have been always a source of inspiration, and all the administrators present, and then Vice Chancellors, Registrars, because they have given academic freedom, so we can do freely our work in our department. The academic freedom, all the support I have received from our administration and also from all the heads of the departments, our chemistry department. And I have to particularly thank all my students. 17 students have completed, all of them are involved in this type of research, that is defluoridation, heavy metal removal, dyes removal, nitrate phosphate removal, pesticides removal. They are all very sincere. They are all the instruments. They only carried out all these experiments in the laboratory. So I have to thank all my research scholars for their wonderful work, and I thank all the participants for patiently listening my lecture. So if you have any doubt, you can. I am ready to answer. Thank you, one and all.
It was really very, very informative, Akash.
Thank you.
I
Krishna
would
Kumar.
just add one of my personal experience.
Okay.
2 decades before, I used to be falling sick every now and then.
Wow.
One day, I went to the doctor and he asked me, "Ki, what are the things you are doing?" And a specific question put to me was on the water, what I'm drinking. He suggested, it is almost 2 decades now, he suggested that you should have clean water, that is, if possible, a distillery type of water to be used at home as well as when you go away, you have to take it. Uh, Trust me, Akka, this has reduced my medical bill to zero.
Yeah.
Right?
Yeah.
Those days, I really didn't understood what is the importance of that particular suggestion, how it is important. But today, I'm a management student. I did my economics in masters. It's a very different field for me to sit and listen to you on chemistry. Really, it was from core of my heart, I'm telling you this. It was like a discussion, not a lecture, not a webinar. It was a discussion, very, very, very simple language a layman can even understand. And the flow was so amazing that you have that when you are watched in the classroom, the same kind of posture, very cool, composed, and you were on your floor without any external disturbances, what I have seen generally, which is there in this kind of webinars, where you are not seeing your students, right? Really, I'm thankful to you, Akka. It is the kind of work you people do at Gandhigram is not visible to many of the people who are sitting in places like Delhi, where uh, uh, things are decided, right? Uh, as you rightly touched, extension program is very, very important for an institution, higher education institution. And the way Gandhigram perceived this extension education, and the way you people as a student and now as faculty, how you are taking it further to reach out to nearest villages and understanding the problems, bringing out the solutions for those things is commendable. It's rather commendable. Questions, you have given no rooms for questions because that is how you have explained everything. It, it, it is a genuine thing, genuine problem for the students also, but still, genuine problem for the students also. Now, I have, yes, we have received a couple of questions. Uh, let this question has come from a student who is from arts side, not from science
Science.
side. Right. There is a once again, there is a nature activist who is using husk to clean lake in Bangalore these days. Uh, how good it can be, how effective it can be in
Yeah.
terms of cleaning water.
In the initial stage of my lecture, I have mentioned all the waste materials, they are, after carbonization, they can be used as a water purifier. But the thing is, for a transfer of technology, the sustainability is little questionable. But at a domestic level, we can use those husk material. But we have to we cannot reuse the same material, so we have to replace it. So husk can be used, but as such, husk cannot be used after because that will impart impurity to water. Okay, after carbonization, that is proper modification, as carbon, they can be used as a water purifier. It can be used.
Thank you. That's a good question. Now it followed by carbon cleaning.
Yeah.
It came to my mind. This question is from Yaka. How effective is carbon cleaning vis-a-vis the mineral water sort of thing?
Yeah, now even now carbon is considered as one of the best adsorbent. It is best for removing colored impurities from water. And carbon, in many of the water filters, they are using sand. Sand, it is able to remove microbes present in water. So carbon filter, sand. So a filter which may have a carbon, sand, so it is able to remove physical impurities and microbes. So at a small level, we can use it.
Okay. Now, how effective is this reverse osmosis in terms of drinking water?
Yeah, reverse osmosis, it is one of the best method identified for the removal of salts from water. It is mainly used to convert seawater into drinking water. So it is the best method, but the wastage of water is more. To get 2 liters of water, we are wasting some two to double to triple amount of times that amount of water. Anyway, as of now, that is the best method for converting seawater into drinking water. There is no other option.
There is no other option. It is effective. Correct.
Yeah.
Okay, now,
Sometimes we need some minerals for in drinking water. This reverse osmosis process, this will remove almost all the minerals from water.
oh, that's a
So
threat.
that is not good for our health.
Yes.
If our water has minimum levels, that is all the solids or all the ions are within the limit, that water directly we can drink. So
We can
every
enrich. We can
yeah,
enrich minerals at a later stage after doing reverse osmosis. Something is possible.
yeah, but that is not advisable.
Otherwise,
So if all the minerals are within the limit, that water can be used as such.
okay.
We need not in, but now I am seeing in almost all the houses we have reverse osmosis plant. Whether we need it or even they will test only the TDS, total dissolved solids, up to 500 milligram per liter. It is portable, but even if it is 10 milligram per liter, people are using this reverse osmosis.
So we
That
need
we
to
have.
be cautious. We need to be
Yeah.
cautious in using
Yeah,
reverse osmosis. That's what.
and of course, we are getting these minerals through food also. So that will take care.
Okay.
We are used to it.
Now we are used to it. It's a
Yeah.
fantastic word. Optimistic words.
Yeah.
Optimistic word. Uh, okay, in 2050, according to the government surveys, in 2050, the consumption of power is going to be somewhere to the tune of 25 terawatts, approximately. A huge demand is there
Yeah.
in that
For
country.
water also.
Something like that is there for water also because of rampant uh, population increase. You can say. Uh, there one particular part is there which gives a sight of relief for me as a person from outside, that recycling of water is
Yeah.
possible, and we are doing recycling every
Yes.
possible ways. We are doing the recycling process now. How effectively can you use this recycled water for drinking purpose?
Yeah, as I told you, in almost in all developed countries, after recycling, even for drinking, they are using this water
Recycled
for,
water.
yeah, recycled water. At least we can use recycled water for agriculture purpose now
Hmm.
in India.
That we
So
are
now
trying to do
we
on
are
and
trying.
off.
Now we are trying. Yeah, we are trying.
But the possibility of bringing it in drinking water, how do you think
Yeah,
that?
yeah. In developed countries, they are doing it.
How?
Recycled water. They are
For
using it in
us,
Singapore. Yeah, they
okay,
are, for us also that can be tried.
that can be tried. Okay, fine, great. That was a real insight, because somewhere I get relief by experts like you are telling that yes, it is possible. Right. Now, uh, we we are doing something special. Not something special. Yes, it is unique. I should say. Eco-friendly pollutants removal. Removing
Yes.
pollutant is there, but eco-friendly
Yeah.
pollutant removal.
Yes. Yes.
Uh, GRI has contributed for this particular purpose for quite some time, right? As you rightly mentioned, Dr. J. Karthikeyan, from those days,
Yes.
it has contributed to this level. Can you just throw some light on this contribution part of it for the entire world? Gandhigram's
Yes.
contribution in eco-friendly pollutant removal. Finding out
Yeah.
beyond it.
See, we have used, I have mentioned in my earlier part of the lecture, many materials we have tried. All many adsorbents we have tried. We have selected this biopolymer, chitosan, as the best material, not only because of its ability to remove the pollutant, but also because of its eco-friendliness. It will not cause any secondary pollution. Using this chitosan, we are the pioneers, I can proudly say, only in Gandhigram. And not only in India, all over the world, we are using chitosan as the material for removing pollutants from water and wastewater.
We are pioneers in
Okay.
that.
Yeah, we are pioneers,
There you are.
and we are,
That's what I want.
and I hope we will develop some technology for removing pollutants, a particular pollutant, or in combination. We will develop a model for the society, for the benefit of the society. I hope so.
I'll pray to God Almighty that our institute should find something like this, and we should be there as leaders in contributing to the mankind.
Thank
The
you. Thank you.
highest level of contribution, what we can do to the mankind, is this. I pray to God Almighty that it should come up, and I would personally. I'll be with you. I'll come whenever I come next. I would sit and understand what kind of research is going on and how we can bring in funds for that particular thing from others also.
Sure, sure. Thank
Uh,
you. Thank you
in
so much.
in general, through this webinar, I request all the people, those who are going to see, or those who are wrote in, whoever is in a position in India and abroad, to reach out to Gandhigram Rural Institute to contribute in this particular fashion by bringing in resources, money, or lab materials, or whatever it is. The best possible way of doing contribution in this particular aspect. I request all the viewers to come and generously contribute to Gandhi Composer Institute in this. It's now by heart. Yes, it is not till now, but yes, I have to, because of time constraints of you and your commitments. I'm really thankful to you, Akka, for spending this much time in our webinar series and enriching us in various aspects which are probably unknown to people like me, those who are sitting outside the purview of chemistry as a subject. But yes, the contributions, whatever has been done by you and your team and your predecessors like Dr. T. Karthikeyan, Dr. Aparab, there is no match. there is no match.
Yes.
Sitting in earlier days and visualizing such things and contributing something towards that is something great. I should formally close this webinar series. So I would uh, I would go to that particular part now. It's really great to have Dr. Meenakshi, professor of our institution, to come and speak on a title: Removal of Toxic Pollutants from Water Using Biomaterials. This, I'm sure, this webinar should be an education material for some time people to come and refer in future also. It is available on YouTube. I'm really thankful to you, Akka, and for the time you have given to us in this particular webinar series. Thank you. Jai Hind.
Thank you, Dr. Krishna Kumar. Thank you so much.
Jai Hind.
Thank you.
Can move out, Akka.
Okay.